Hi guys, today we're going to cover section 3.1, the graph of functions. Just a few things that we need to know. Make sure you know the definition of the graph of a function. That is on page 295. Essentially, the graph is a collection of all the values of input and output in the formation of a bunch of dots, and then we connect them. Okay, we'll do more about the definition later, but that should get you going for now. And we'll talk about the vertical line test, the function notation, domain and range for sure, and the parent function. Okay, there we go. All right. Number 2, part 1, graph each function and identify the domain and range. So I graphed it for you on Desmos, right? So if you graph this equation, this function into your calculator or using Desmos, this is what it looks like. Okay, and but let's just remind ourselves what's domain and range. My definition for domain is all the x values that work, and my definition for range is all the y values that work. Sorry, I couldn't really think of a mathematical way, right? So I figured work should do the job. Okay, so let's look at the domain first. Remember, domain is your x value. So if you look at this graph, right, remember x goes left and right, y is up and down. So as you look at this parabola right here, notice it just keeps going and going and going to the left, and it keeps going to the right, and you don't see any kind of gaps or breaks. So if that's the case, our domain in this case is going to be from negative infinity to positive infinity, because it just keeps going to the left, keeps going to the right. Okay. Now range is your y value, so which means we're looking at up and down. Notice as the graph comes from left to right, your y value goes from positive infinity, which is all the way up, all the way down to negative 4, and then curl back up. So which means the smallest value of your y value is going to be negative 4, and then it's going to curl back up. Okay, so that means my range in this case is going to be from bracket negative 4 up to positive infinity. Right, and remember, interval notation, lowest is on the left, highest on the top, highest is on the right. So therefore, my lowest value for my range is going to be negative 4, and my highest value is going to be a positive infinity. Okay, domain is left and right, range is up and down. Okay, all right, we'll look at a couple more examples, and hopefully you'll get more familiar with this. All right, here we go. This is the graph of the negative absolute value of x minus 3 plus 2. And I already incorporated a few points for you. Notice this is kind of like a V shape, except it's upside down. As you look at your left and right, as you look from left to right, it just keeps going. It's continuous. There's no gaps, right? No gaps, no breaks. So your domain is going to be from negative infinity to positive infinity, because you can find any x value you want here. There's not going to be a restriction. Now range. This time, again, range, we're still going to have a restriction. Notice, the highest point you're going to see is 2. Right? The range is your y value. So your highest y value is 2. your lowest y value, right? These just keeps going. So your lowest y value is negative infinity. So for the range, we'll go from negative infinity up to 2. And we include a 2 because that's an actual point on the graph. Okay? Alright, next one. Little curveball. This is the graph of square root of negative 2x plus 1. So let's look at the domain and range as well. So let's look at domain. Domain, remember, we go from left to right. So this graph looks like it's continuous. So which means you'll go towards negative infinity on the left. However, on the right, notice it stops right here. Okay, it stops right here. And with the square root function, it is okay for y to be 0. So therefore, this graph starts from negative infinity from the left, goes towards the right, and it stops at 0.5. And that is our domain. Our range will be very similar. This graph comes from above, right? It goes on high, then ends up low. So that means the lowest value in this case is going to be 0. So it'll be a bracket 0, comma. How high does it go? Well, it goes out to positive infinity. Okay. So yeah. So again, domain is left and right. Range is up and down, right? And a lot of times when I think of range is, how high can I go? How low can I go? Okay. I'm taking a sip. Okay. Alright, we'll move on to the next one. So number 3, we're supposed to use the vertical line test to determine if the graph represents the function. A vertical line test by definition means this. If a vertical line crosses the graph more than once at anywhere, the graph is not the graph of a function. Okay, so for example, if I just draw a vertical line, say right here, notice it crosses the graph twice. So that is going to be 4, looks like -1, and this looks estimate 4. Actually, that's not -1. This is a -1/2, right? Because the scale is a little weird. And this is 4, negative. Very generous estimate. -5.5. Okay, very generous estimate. And if you remember, right, from the chapter 2, section 1, we talked about the function, and it has to be for every input, there is only one output. And in this case, we fail at the part. There is only one output. Right, that's the part that we failed. So therefore, in this case, this graph does not represent a function because it failed the vertical line test. Okay. All right. Next, this is a graph of a hyperbola. We might have some chance to look at these types of problem later, but again, is this a function? I'm sure you guys probably can just look at it and say, no, this is not a function. It fails right here. Okay, not a function. All right. Part C, is this a function? Well, it doesn't matter where you draw the vertical line. You only cross the line one time. Okay, because the vertical line only crossed the graph once, it is a function. Okay. All right, number 4. Now you have a little bit of a piecewise function going on, and notice this is not your typical graph where it is nice and smooth. Okay, but the idea is still the same. So let's go ahead and find all the positive x-intercepts. Now remember, x-intercept means y equals 0, so which means we're looking at, this is y equal to 0. So we're looking at right here, right here, right here, right here, and right here. Okay, now be very careful. 0 is not positive. 0 is neutral. So the only positive x-intercept we have is x equal to 1, x equal to 3, and x equal to 5, and x equals 7. Okay. Alright, what is the value of P of 4? Now, P of 4, this is telling me, means when x equal to 4, what's P of x? So they're basically saying when x equal to 4, what's the y value? Well, if you look at it, let's see. X equal to 4 is 1, 2, 3, 4. So P of 4 is equal to -1. Now, in this case, for what values of x is P of x less than or equal to -2? Okay, so to figure out this problem, I'm going to first and see when is P of x equal to -2. So our y value equal to -2 happens right here. So this means this happens at x equal -2. Okay, so from here you have two choices. You have either, to figure out the inequality, you have either x is greater than or equal to -2 or x is less than or equal to -2. Okay, now our goal is to figure out when P of x is less than or equal to -2, right? So which means when is our y value right? So we're trying to figure out when is the y value less than or equal to -2. Well, if -2 is right here, that means any of the value that's less than -2 has to be over here. And that happens, this happens when x is less than or equal to -2. Okay, so the answer will be x is less than or equal to -2. Alright. The inequality could be a little weird. Just because going left and right stuff. People have issue with directions, but otherwise the rest should be pretty straightforward. So, problem part C. I think I skipped it. For what value of x is when p of x equal to 1? Well, when's p of x equal to 1? 1 happens right here, so which means right here and right here. So x equals to 2, x equals to 1, 2, 3, 4, 5, 6. Okay. Yep. So just again, a lot of times what you're doing is you're looking for points. So we'll get some more practice for sure. Okay, identify the domain and range of the given graph. So in this case, again, we said domain. Right, so domain in this case, and write it in black, is all the x values that work. And range is all the y values that work. So you look at the x. This graph starts at 0, stops at x equals to 5. So that means the domain is bracket starting at 0, bracket 5, ends at 5. Okay. Now the range. Okay, range is how high does it go, how low does it go. The lowest point for the range for the y value is -1. And the highest point for the range is +1. So that means my range in this case goes from -1 to +1 bracket, because assuming those points are all endpoints. Okay. All right. Let's move on to the next question. Okay. This one I have to kind of do a little bit of improvising, so don't mind the graph. Same idea, domain and range. So domain, left to right. Looks like it starts from -3, ends at 5. So my domain in this case will be from -3 to 5. Okay. Now this time things is a little different. I have the open circle instead of the solid dot. So that means open circle it's a parentheses, and the solid dot it's a bracket. Okay. So this right here is my domain. As far as range goes, again, how high does it go? How low does it go? The lowest point for this graph is at 0. The highest point for this graph is at 1, 2, 3, 4, 5, 6. So our range will go from bracket 0, because this is the actual point, the 3 zeros is an actual point on the graph, to solid to a 6 with parentheses because of the open circle. Okay. All right. Okay, the last graph. This one's a little weird. This is your exponential function. Okay, so exponential function, you should have learned in the previous section, class, that it just keeps going and going and going. So our domain in this case is from -infinity to +infinity, because this keeps going and going and going and going. Now range. Notice the line flattens at 1, 2, 3, 4. at -4, right? The line flattens at -4 from above. So which means what this tells me is this will get really close to -4, but it doesn't ever touch it. So our lowest value in this case will be a -4 parentheses. And if you look to the right, as the graph goes to the right, the y value keeps going up. It goes as high as you can, so which means this one is going to positive infinity. So positive infinity. All right. So this is it for the graphs. Finding to see if a graph is a function should be relatively easy. Hopefully the vertical line test will do you well. And if you got any questions, please let me know. You can post the problem on the forum, Blackboard, or you can shoot me an email, whsieh@grcc.edu. All right. Good luck. I'll talk to you guys later.